All right. Welcome everyone. Welcome to UCD. I know it's a cold January evening, so really appreciate everyone making the effort and putting away the time to come in and visit us today. So my name is Philip Donlan. I'm a lecturer in chemical engineering. I'm just going to be more facilitating tonight than anything else. And look, what we really want to achieve, I suppose, is you've all come here with a view to try and learn a little bit more about what engineering is in UCD, what the different type of programs are, what you're going to learn as you go through, what happens afterwards, etc. We're going to try our very best over the next hour with the various speakers that we have to try and address those, I suppose, queries and interests. And then we're going to give you the opportunity to engage with a bit of a Q&A afterwards. So the one thing I would say, look, we're all here, everyone's made the effort. Let's make sure you get as much from this as you possibly can. We're all here literally to try and give you as much information and answer as many questions as we possibly can in the time. So don't hold back. If there's anything you're wondering or if you're half wondering, just make sure that you, I suppose, give us a chance to try and answer it for you. So look, we have a great lineup here tonight. I said you'll be seeing, thankfully, a little of me as we go through. We've a much better cast than that. I'm just going to introduce them here at the very start, and then as we go through, we'll just kind of roll from speaker to speaker. So we're going to kick off with Professor Paula Burke, who is the head of School of Biosystems and Food Engineering in UCD. Paula's going to give us an overall introduction into what engineering is in UCD, the different programs, etc. So that's going to be a good kind of, I suppose, piece to set the scene for everything that follows after. After that, then we're going to move over to Nicola Fortune, who is from the Careers Network here in UCD, and she's going to give you an insight into, I suppose, what the career pathway looks like when you come and you join us. So we all know that it's important to go through the 4 or 5 years and learn as much as we can, but ultimately, I suppose it's the first step in your careers, whatever that's going to look like. And we want to talk through what kind of sports are available and I suppose what that means for you as an undergraduate student going through. And many of you, I suppose, that are kind of here tonight are going to be also thinking what it's going to be like Monday, Tuesday, Wednesday, Thursday, if you actually do join us. So with that in mind, we have Grace Power with us from the School of Electrical Engineering. So Grace is a third-year student and is going to give you an insight into, I suppose, the day-to-day, what's it actually like being an engineering student in UCD, and hopefully give you a really good insight into, I suppose, what it looks like on a day-to-day basis and what you can expect. And then we're going to finish up with Eleanor Thornton. So Eleanor was a student of ours in chemical engineering a couple of years ago and is now a senior manager in supply chain in BMS. And Eleanor is going to give you, I suppose, the graduate perspective. What's it like when you come out the other side? What can you expect from your career? What are people doing, etc., etc. So again, just trying to give you the various different, I suppose, stages of the journey as you go through. Hopefully, I said the talks will give a lot of information, but then after that, what we're going to do is we're going to bring everyone up. At about 7:30, then we're going to have everyone up here. We're going to open the floor. It's going to be a Q&A session. Whatever you're thinking, whatever you want to ask, please do, and we'll all do our very best to answer it, whatever those questions happen to be. Okay, so with that in mind, we won't do questions after the individual talks. We'll hold them, and then we'll do all the questions together at the end. So without any further ado, I'll hand you over to Professor Paula Burke. And
oh, sorry. Okay, thanks very much. Okay, so good evening, everybody. I hope you can all hear me at the back. So as Philip said, thanks for the introduction, Philip. My name is Paula Burke. I'm the head of School of Biosystems and Food Engineering here at our UCD College of Engineering and Architecture. So what I'm going to do for the first 10 minutes or so is give you really a whistle-stop run through some of the main undergraduate offerings that we have within UCD Engineering. So first of all, what we're going to do though is I'm just going to show you a quick video, and this is from Engineers Ireland, and it kind of gives you a flavour of what you can become and what you can do as an engineer, and the different areas that you can engage with. So I'll just play that now. Just listen to this first.
Will you come with me? Across bridges and railways.
To feel the Atlantic's wave power.
To brave new worlds. From the rudder to the engines. to making monsters.
These things are there for me and you.
From purifying water with reverse osmosis.
From apoptosis.
Multiplayer online gaming, clearing minds, and saving lives.
There for me and you.
Goddard Engineers, bringing dreams to life for me and you.
Okay, so that was just a quick run through some potential avenues that, that utilize engineering and that you can end up doing from an engineering degree perspective. So, but let's get down to, some of the more interesting things, I suppose, for yourselves. If you're interested in applying to an engineering degree here at UCD, the code is DN150, so that's absolutely clear to everybody. So how many points do you need to actually get in? How do you need to perform within your Leaving Cert exam? So over the last couple of years, it has kind of consolidated around 566 points. The asterisk means that not everybody at that point level did actually secure a place, but that is the level you're aiming for there as a minimum points level. So you do need 6 Leaving Cert subjects. We have to include English, Irish maths, at least 1 laboratory science subject, and then 2 other recognised subjects as well. So within UCD, in terms of the laboratory science subjects, we recognise physics, chemistry, biology, ag science, but also phys chem as well is a recognised science subject. So that one can be included as well. So the next thing then is really, once you get in, how do you actually learn? What do you come across when you get in here? So you're this evening in a very lovely theatre. This is in the UCD Sutherland School. Many of the buildings are like this. Some of them are very large theatres like this. Some of them are much smaller. And, it really depends on what module you're doing and what structure, what program you're actually doing as to what type of delivery and what type of learning and what type of assessment you might actually get. So obviously we have lectures, the fundamentals of each of the key subjects. Certainly within first year, you'd have your physics, you'd have your chemistry, you'd have your maths, very much delivered in a lecture format, but also there would be a significant emphasis on the laboratory and the hands-on and the practical elements of learning how to generate data, how to utilize that data when you generate it, how to analyze to generate data. Basically conducting experiments. So you would learn the basics of doing those, if building on what you got from secondary school. So you'd be learning how to use a wide range of instrument types and actually do those measurements and learn the principles and fundamentals of how those devices and those analyses work. Once you've done analyses, you get data, and data underpins so many engineering streams at this stage, and basically how you interpret the data and how you can work with data is very, very important for many streams now. So we'd have lectures, we'd have laboratories, but we'd also then have smaller group experiences with tutorials, and these might include a number of teaching assistants or demonstrators to actually assist with the lecturer or the professor that is delivering the module. So you'd have an opportunity to have a far more, much smaller group and much closer interaction with a range of people. So the next thing then that is definitely included in each of the programs are a sequence of modules that you would get the opportunity to incorporate engineering design exercises into what you're learning. So even in first year, there would be 2 examples of 2 modules. There's a creativity engineering module, but also there's a biosystems engineering design challenge. So those are the type of modules that you would work in small groups. It's very much problem-based learning. So you're given a problem and you've got to figure out how you're going to solve that problem within a group setting. And you've got to then come up with an idea. You've got to progress out your idea and present that idea. And that is how you're actually assessed for that type of module. So you get that opportunity to go away, work within a group, research how to fix something, how to solve a problem, come back and get your ideas kind of discussed at a class level and progress those ideas. And then also there is project work. There's a very strong element on project work. So this could be a research project, a smaller research project within, first or second year modules, and building up as the years go on into a capstone or a research thesis, a dissertation towards the end of your program. So there's a wide range of different ways that you would be able to learn. So what I'd like to just run through then is basically the overall structure of the program. So we have a common first year in UCD. So we do that in order that you actually are in the university for the guts of a year. And then it is at that stage that you make your choice on what, to consolidate your choice on what area of engineering you'd actually prefer to go through. So there's in year one, there's the basic fundamental modules. Everybody does the same core modules. So you're going to have your physics, you're going to have your chemistry, you're going to have your maths, you're going to have introduction to engineering, introduction to design, creativity and design. And then you also have the option then to choose a number of modules, up to 2 completely different option modules. So this is where you might have the opportunity to pick up a language if you so wanted. You might have the opportunity to pick up an economics module if you so wanted, or you can stick to some of the other engineering option modules that are also available. At the end of year one, that is when we come back in, all of the different schools and all of the different majors. So each of the main programs would give each of the students an overview of the different program structures in detail of what you could potentially do. And it is at that stage then that you make your choice of what pathway you're going to choose for years 2 and years 3. And this is where you start to specialize. So you could pick a pathway at the end of year 1 and you can start to specialize. And I'll go through each of those kind of main pathways now in a few minutes. But they're primarily biomedical, chemical and bioprocess engineering, civil engineering, electrical or electronic engineering, and then we have mechanical engineering, and then we've also got structural engineering with architecture. So each of those you would choose then essentially that towards the end of first year, after a little bit of exposure to the general first year and an introduction to each of the potential pathways that you might be able to explore. One of the features then that is offered within year 3 is the opportunity to study abroad, and everybody gets this opportunity. It is dependent on your academic performance. You do have to achieve a certain level. You'd have to have a grade point average above a certain level, usually around 3, in order to be eligible to undergo a study abroad term. But there's huge opportunities within that to go. There's great networks of collaboration with other universities, with UCD, and it's a supported scheme. There are some financial supports to actually assist students to apply for different financial supports from EU supports and from university supports. So it's an excellent way to build in a bit of a different experience to what is essentially a relatively prescribed program of education. It's where you can choose to go abroad and do something different in a different university, and you can put an individual stamp then on your own module, list or choices that you might do through doing that study abroad option. So then the next phase that you actually get to choose then is towards the end of that year 3. You get to choose again then if you're going to specialize a little bit further. So within each of the choices that a student would make at the end of first year, if you went into a particular stream, there's another option at the end of that 3rd year, after doing 2 more years, within a more specialized stream that you can, potentially choose to specialize a little bit further. So that option is there again. So at this point, you can choose in many of these areas whether you want to do a 4-year degree and graduate with a Bachelor of Engineering, or if you wanted to continue and do a 5-year program, and that is when you get a Master's in Engineering. So from the point of view of the BE or the ME, there are some, different specializations within each of these as well. And it's very much up to yourself, what is the best pathway for you at that stage. But you would have been in university for a few years at that stage, and you can make that choice. So that is made then towards the end of 3rd year. Okay. So what I'd like to do then is just maybe give a very, very quick run through each of the key areas. So one of the first ones there is electronic and electrical engineering. So, what do you actually end up doing? Where do you end up if you do an electronic or electrical engineering? So you're very, very familiar. This is how we, how we communicate, all the devices that we use, the smart devices that we use, that's very much based to communicate. Music, all of those different things are using electronic devices, and the design and the build of those is, within the remit of electronic engineering. Another big area within electrical and electronic engineering is from an energy perspective. And this is extremely topical at the moment. And, you know, how do we devise systems? How do we devise approaches to generate sustainable energy and sustainable power, etc.? So they're kind of two big areas within electronic and electrical engineering for that particular focus. So a lot of the graduates then would work in the ICT area, working on different communication systems, looking at advanced digital technologies. Now, digital technologies do actually come across all of the areas of engineering now, because utilizing sensors of different builds or different constructs to actually capture information and capture data really underpins nearly every area of engineering now. But again, as I said, so different types of energy, how can we build different energy supplies to power the things that we use for our everyday lives? There's extremely good links with the industry in Ireland, and you know, there is significant investment going on in the electrical and the energy systems within Ireland. So, you know, there's very good prospects within this area as well. One of the other kind of mainstreams that you can choose towards the end of first year is biomedical engineering. So this, you know, what does that involve? It can involve applying your traditional engineering knowledge and methods, and you're basically taking that and applying it and solving problems that have a biology emphasis and very much within the medicine and healthcare applications. So, you know, it can span, it's quite a broad area, and you can span to, you know, device design, materials design for those devices, and, you know, utilizing different materials for implants or for prosthetics, or, you know, really we're operating here at biomechanical kind of space that is at the kind of the edge of the cutting edge of research. Now, Ireland has a very, very strong biomedical record, and it's one of Europe's largest medtech hotspots. So there's nearly all of the companies globally are based in Ireland, and there's great innovation within Ireland in this space as well. So there's a lot of smaller and medium companies as well that are national as well. So what do you end up doing? You know, we're talking about designing devices, designing new medical instruments that might not necessarily be an implant, but used to measure or to analyze for a particular disease or issue, and basically developing technologies or researching different health problems and using different technologies to help you do that. With biomedical engineering, there's a fair bit of overlap or complementarity, certainly with materials engineering. So that is something you can choose at a later stage within at the end of year 3 as well. So some of the advances within this area in terms of technology would, and a lot of the research work and that is being integrated into the modules within UCD would involve different processes such as 3D printing. And, you know, you're really at the cusp of things changing there, you know, integrating different types of materials into the manufacture of different scale, you know, analytical devices or implants. So combining different materials and looking at the compatibility of those materials, the functionality of them, and how they work or don't work even, you know, when they're implanted into a person. So there's a huge amount going on there. And even with the advances in biomedical engineering and materials engineering, it's now moving on not just to 3D printing or even 3D bioprinting, but looking at 4D printing, which is looking at the design of these devices so that the materials themselves can respond and harness the properties of those materials to actually form the structures that are needed and be responsive when they're in different environments. So it's a very interesting area. So the next mainstream then that I want to run through quickly is mechanical engineering. So, you know, nearly every process or nearly every manufacturing process, not just in Ireland, but globally, generally speaking, has a mechanical engineer involved in the design of that manufacturing process. So it's how things are made. So it's really integrated into lots of different applications, looking at designing and developing new energy systems, how they're actually delivered. Another kind of growing component within mechanical engineering is robotics and the use of robotic arms and robotic systems in manufacturing and the control of those and design of programs for those, but the actual build of them as well. The design of new communications devices, of new entertainment devices, but also then in the actual use of those energy sources, what types of engines, what types of way are we actually utilizing the engine? So all of those aspects need some sort of a mechanical design approach. So mechanical engineers are involved in a wide range of sectors and industries. Interestingly, the mechanical and materials engineering degree then is actually double accredited, not just with Engineers Ireland, but also with other international organisations. So it can, you know, bring you far. And then not least, but we've also then got chemical and bioprocess engineering. So it's another very strong area, sector within Ireland, the pharmaceutical sector and the biopharmaceutical sector. So within this, you can do a chemical engineering or chemical and bioprocess engineering. So chemical engineering is really looking at different ways of manufacturing or how we can actually get to manufacture you know, common goods such as, you know, chemicals that we use every day, or even including foods and different beverages. We also then have the whole pharmaceutical approach there. Now you can manufacture those through a chemical engineering approach, or you could also manufacture those through a bioprocess engineering approach, which is actually utilizing cells, whether they're human cells or mammalian cells or plant cells or insect cells or even microbial cells, and actually utilizing those as factories to manufacture compounds that are used in our healthcare system or even in our diagnostic system for a wealth of different applications. So basically what you're looking at is the efficient and large-scale manufacture of medicines through bioprocess or chemical engineering. But there's another element to that as well, as these products are manufactured at such huge scale that the actual plants that are involved in their manufacture also require a good amount of understanding of how the chemistry will work, how the bioprocesses will work, and there's specific plant design involved in that as well. So there's a few different elements there, and that would of course incorporate some element of materials and mechanical design as well. So just another one to note for this particular degree, this is also accredited then with iChemie at master's level as well. And then we also have civil engineering. So this is very much how we are constructing and how we are engineering the environment, the built environment around us. So this is again, very, very topical area. There's huge investment going on in Ireland in regards to transport and with regards to, you know, the build of public resources, different buildings, different hospital infrastructures, healthcare infrastructures. All of those require, you know, a design and an engineering approach for them, because they are structures that are going to serve, you know, particular purposes, but they also have to serve wide range of, you know, interact with a wide range of society. So all of those things need to be taken into account in, you know, in inclusive civil structures. So it's really, you know, infrastructure development for, you know, actual buildings, or transport or roads. So there has always been a strong emphasis, but it is certainly increasing on, you know, how can we make these structures and our built environment sustainable and also inclusive. So these are kind of aspects that are explored a little bit further as well. It does relate very much to, you know, the inputs and that we use as a society, such as water, how it's moved around, how it's used, how it's cleaned up. So there's a lot of water and wastewater engineering in there as well, but also from an energy perspective and how those things are actually interlinked. Because this particular area is very involved in, you know, perhaps developing public structures that require a lot of investment. There's a strong emphasis also on project management and actually, you know, the tools to actually allow you to do that as well within the civil engineering program. And then last but not least, we have structural engineering with architecture. So this is a sub division of civil within civil engineering as well. So this is really for that large structural piece. It's not necessarily related to the environment, for those large structural pieces and how to design and build those safely. That is very much the focus of structural engineering with architecture. So the areas that are, you know, primarily graduates of this area will go into work in construction, but also in project management, but also in planning and engineering and management consultancy aspects as well. Okay, so I'm going to leave it there. As I said, it was a whistle-stop tour through most of the main areas that we offer our undergraduate provision in. If you are in your final year, if you're going to be applying to the CAO this academic year. There is a possibility that there might be one more offering in terms of sustainable systems engineering, but that would really only come into light maybe when you'd be going into second year. Okay, so there's a lot of advantages to doing engineering at UCD. In general, there's huge diversity of modules that you can choose. You don't have to choose until you've already done most of first year. So there's great freedom and a great flexibility in learning a little bit about what you might want to do. You might have an idea already, but you still have the opportunity then to learn a bit more and change your mind, and also interact with the various different areas that are on offer to actually make a really informed choice when you're in situ. Okay, so thank you very much, and I'll take questions then towards the end.
So good evening, everyone. My name is Nicola Fortune, and I'm a career and skills consultant here in University College Dublin, and I work particularly with the College of Engineering and Architecture. So it's lovely to see you all here this evening, because I know it's very cold outside, so there's definitely a temptation maybe not to come along. So it's great you're here, and I hope you take advantage by actually talking to us afterwards, as well as maybe talking to some of the students on the stands. So I'm going to be kind of continuing on from what Paula was talking about, and talking a little bit more, I suppose, about what happens afterwards. So what happens after you finish up at UCD, as well as kind of other ways that you can work while you're in UCD to work towards your eventual goals. So when we're talking about kind of engineering as a career, so it's just to start off kind of thinking about what's an engineer and what does that look like. So obviously Paul already addressed this to a certain extent, but really I suppose one way to think about engineers is they're quite practical people. So engineers tend to make things happen, I suppose. So it's really obviously using science and maths, but applying that knowledge to the real world. So sometimes that can kind of help you visualize what you could be doing. Actually, it's not just ideas. It's how do you turn those ideas into reality? How do you solve problems? How do you move things forward? So obviously we mentioned, or Paula mentioned already, there's lots of different types of engineers, and there's lots more types of engineers again. So these are some of the general ones that we're starting off with, like civil, chemical and bioprocess, those ones, but it does actually go even more detailed than that. But as well as working in these specific disciplines, once you actually look out, I suppose, in the world, you will see that engineers are absolutely everywhere. Sometimes you'll have two engineers who have completely different qualifications working in the same role even. There can be lots of overlap. You can be quite surprised. So again, this is a quote from Engineers Ireland. So you'll find engineers in almost all industries, from aviation, agriculture, space, healthcare, manufacturing, software. So it really is kind of, I suppose, at the heart of everything. But when you actually study as an engineer, it's not just about becoming an engineer always. Sometimes it can also be about the skills that you learn along the way. So there'll be those technical skills you're going to learn that might be specific to the particular area that you're most interested in, but also you're going to develop a huge range of transferable skills. And as you kind of go through your education and through your career, you might find that you really enjoy or you really excel at certain aspects, and that'll kind of drive your career in certain areas. So when we're thinking about engineers and we're talking about transferable skills, obviously just some things are going to come to mind, like you're probably all quite good at maths. I'm going to guess that most of you guys, you're okay at maths. But again, when you actually study engineering, you'll find that a lot of it is about solving problems. It's about actually interacting with people. It's about working in teams. It's really about, I suppose, those things that you can take out of a technical situation and actually you can apply them in so many other areas in the world. So it's really interesting sometimes to see where engineers end up. So there's such a wide range of options there. So in terms of, I suppose, my area is careers, obviously, so I work with the Careers Network. I will work with students, I suppose, from day one. And what I'm going to talk about in a minute is how we can work together. But I'm sure you guys already know that it's not that hard because the job market is fantastic. So it's not too tough a job we have. When we're talking about kind of how things are at the moment, one thing that can be interesting to look at is, for instance, Obviously, if you want to work in a particular country like Ireland, you might want to look at the accrediting body, or you might want to look at kind of the relevant, professional bodies like Engineers Ireland. So every year, Engineers Ireland publish a barometer of the profession. So if you're curious, you can Google Engineers Ireland barometer of the profession, and you'll see kind of all of their chartered members are actually surveyed every year, and there's lots of really interesting information there. And so they're asked questions along the lines of, do you think there's, plenty of jobs? And you see 85% of, actually you can't see it probably there, but 85% of this year's survey said, yes, there's plenty of jobs. Similarly, 72% of this year's surveyed employers said that one of the key barriers they see is actually the shortage of engineers. So again, the market is very positive. But it is always useful to maybe do a bit of your own research. If you're interested in working in different countries or in specific streams, it's always a great idea to actually kind of dig in a little bit yourself. So in terms of, I suppose, typical salaries, I feel like I have to share this because it's always really interesting for students, especially at your career stage. I've pulled this from Engineers Ireland barometer from this year. So you can see here, it's a very positive picture. So again, we can never say what the market will be like at any given time, but just to give you a snapshot of where we are right now, we see that our engineers are actually doing quite well immediately out of their degrees. And obviously that will vary because some students will have particular interests in some areas that might pay more or less. It'll vary depending on the areas you're working in, the particular types of projects you want to work on. But this gives you kind of a bit of a ballpark of where things are. We do actually survey our own students as well. So this is kind of a national level. So this isn't particular to UCD. So we do survey our own students as well, kind of to see how they're doing. So every year we contact our students 9 months after the graduation, we kind of go, what's going on now? Just to get an idea. And what we find is they do tend to be doing quite well. So for the UCD itself, we are actually ranked #1 in employability in Ireland. So kind of 5 years in a row, which is great to see. Looking at the College of Engineering and Architecture specifically, and this is our graduate outcome data. So as you can see, about 25% of our students go on to further study. So a lot of that would be, say, for instance, going on to do the 2-year ME program after doing the 3-year undergrad. Or it could possibly be doing something else. So it might be converting into a different area or specializing further in a different location. And then 70% go directly into employment. So this is a very positive picture. So we can see we have, there's actually less than 5% who are either seeking employment or engaged in other activities like traveling or, whatever else they might want to be doing. So that would be considered a very positive picture. Looking at the different employers we have, I'm sure you're kind of familiar enough with a lot of these different logos. So obviously we have very strong links with employers both in Ireland and internationally. Something that can be kind of fun to do sometimes is if you want to have a look on LinkedIn, for instance. So if you go into LinkedIn, you can actually do an alumni search. And you can look up University College Dublin, then you can see students who are studying the course, and you can go, where did they go afterwards? And you'll see what companies they're working in, what types of jobs they're working in. So it's always kind of an interesting activity to have a look at. So that's something maybe to play around with if you haven't before. So again, these are just some of the types of employers you would expect to see our graduates working with. In terms of, I suppose, just a nice little thing I had to add in there. So there is a little bit of a premium. So UCD graduates do actually earn a little bit extra, again, on top of the engineering kind of qualification at national level. So this is just some data from 2022. But again, a lot of that was really just to kind of set the scene to say, obviously it's a positive market. It's a really interesting area to be getting into, but you still need to do your part. So obviously a lot of this comes down to you. We're not saying that you'll be handed anything if you do this. It's that you have to actually be competitive and you have to work the whole way through at actually developing that profile so you can get what you want and so you can have as many options as possible. So that's really where the Careers Network comes in, as well as your academic staff and faculty in the college, and I suppose the whole university community really. So thinking about how can UCD support you actually to be in that position where you can choose from the range of options that really appeal to you and are a good fit. So some of the things to consider really are actually just even making sure you're familiar with what are employers actually looking for. So is it enough to kind of go to class and do well academically? Will that give me everything I want? Maybe. But maybe you can actually, again, make yourself more competitive by considering the range of different things that employers look at as well. So again, this is just a quick snip from a survey of employers nationally in 2023. So you can see kind of these are the things that employers say that they look for when they're actually hiring. So obviously they're going to look at things like what you studied. So again, if I'm looking to hire a particular from a particular discipline, that's going to be quite important. And they are interested in things like your academic success. So, you know, getting a 2-1, these kind of things, it is still important. But it's not just that. So again, employers are interested in students who are engaged in their community, who are members of clubs and societies, maybe take active roles, students who have maybe part-time jobs during the summer, students who kind of have a broader, I suppose, exposure. So again, we really want you thinking about that from day one. It's not just about academics, even though those are key. It's also about the broader picture. So what can you do to make yourself, I suppose, as employable as possible? So part of that, I suppose, is giving you opportunities. So some of that just comes down to on a university level. When you're a student in a university, you have lots and lots of opportunities. Sometimes that can be hard because there's so much going on that it's hard to know kind of where to engage. So again, there is over 70 student societies here on campus and 60 sports clubs. So there's student societies that relate to specific areas like, you know, ChemSoc, ElecSoc, these kind of things, EngSoc. But there's also ones that relate maybe to particular interests. It might be something that you're not actually currently studying. Maybe you want to join the Investors and Entrepreneur Society because actually you have a bit of an interest in that area. Or maybe you actually want to get involved with, again, there's the Harry Potter Society. So it might not necessarily be exactly related to what you're studying, but you might have an opportunity to develop skills while you're in these spaces. So for instance, attending events, hopefully you'll make friends, but maybe you'll also have a chance to help organize something, help market something, get involved in different kind of ways. As I think Paul already mentioned earlier on, there's also opportunities to do things like study abroad. So we have partnerships in a number of different areas. So, and again, those partnerships are designed to ensure that you actually still meet your academic goals. So it's very much a matter of ensuring that everything is mapped out and you're actually going to still reach the same goals as you would be here. So that's one thing to consider. The other area really are, I suppose, things like internships. So I know it seems like a really long time away, but as you go through kind of your college journey, you'll hear about internships and part-time work and things like that. That's very much something we would encourage our students to be thinking about as early as possible. So again, I don't expect you to be doing an internship in first year, but it's nice to be starting to think about it a little bit. What will you be aiming towards later on? So again, internships are things that you can do during the summer. So you can just do a regular internship over the summer holidays, maybe in third year, for instance, that could be an opportunity for some people. But also if you choose to do the master's program, which is the 2-year ME program, so that would be the 5-year program that Paula mentioned earlier on. As part of that, in 4th year, you will have opportunity, you'll have a requirement basically to go out for 6 to 9 months on an academic internship. So that's an internship at one of the companies that you might be interested in working with long term, giving you a chance to actually see whether or not it's a good fit for you, and also finding out a lot more about just the working world. So we very much support you in that. So some of you may have met one of my colleagues earlier on at the stand beside me. So that was Eileen and her colleague Fanula. We have internship managers here in UCD who work with our students. So again, there are opportunities and there is support. So other things to consider again are, I suppose, the different ways that we work with you at the Careers Network. So you can see we have our little booklet here. And if you want to pick up a copy of this, it's on the stand afterwards. There's also a QR code there on the stand if you want to just download it kind of to have a copy that way. So the different ways that the Careers Network works with you is very much, I suppose, maybe different points in your own career journey. So in first year, you might not be wanting to talk to us too much, but we're probably going to try and find you. So again, from your very first week, we actually come out and we talk to you in I think on the first Wednesday of term, you'll have sessions with us. And then at various points throughout your time in UCD. We also run regular employer events. So for instance, we would have 4 large-scale recruitment events throughout the year. So for many of you, the most interesting is probably in early October, we have the Science, Engineering and Technology Fair, which is an enormous event. Lots of employers there. You have a chance to come and meet people, find out more. But we also have smaller scale employer events where it might be kind of like a lunchtime event where it's one employer. Other things that we would offer would be a vacancy portal. So on our website, you'll see things like obviously employers come to us and they want to advertise directly to our students. There's a whole range of online resources there as well. So there's a very big suite of online tools and resources that you can access once you're a UCD student. But obviously kind of the human touch can be useful as well. So we also have one-to-one careers appointments. So if you want to come and have a talk with myself or one of my colleagues, whether you're a current student or for 2 years after you graduate, you're very welcome to use the services, as well as things like careers workshops. So you can see these are some of the supports that are available to you. And again, at different points in your journey, some of them might be more interesting than others. So maybe in first year, you might just want to have a chat with us because you're thinking about getting a summer job and you want to hand with your CV. Maybe by the time you're in third year, you're thinking, actually, do you know what? Not really sure which path I want to go down. I want to have a chat about my plans, or maybe I'm interested in doing the academic internship next year. How do I set myself up for success? So really depending on where you are, that's where we want to meet you. As I said earlier on, I am going to be on the stands afterwards. So I'm going to hope that maybe if anyone has any individual questions you want to come and have a chat with me about, I'd be really happy to talk to you. But now I'm going to pass you on to someone who can talk a little bit more directly about the student experience. Yeah, Grace.
Hey everybody, first thing I'd like to say to all of you is welcome. As you guys know or just heard, my name is Grace Power and I'm currently studying engineering, electronic engineering to be specific, here at UCD, and I'm in my third year. So I'm just going to talk to you a little bit today about why I chose engineering, why I chose UCD, what my experience has been like so far, and what my kind of thoughts are for the future. So to begin, I'll just talk to you a little bit about how I ended up where I am. So I'm definitely a subject of a lot of parental brainwashing. You could probably call me an engineering nepotism baby, for anybody who's familiar with that term. Both my parents studied STEM in college. My mum did computer science and my dad did electronic engineering. So there was definitely a bit of brainwashing going on in the background. I remember my dad kind of drawing little Sudokus to do with him on a Sunday morning, or kind of stealing my brother's Lego sets to build before he got the chance. So there was kind of always that in the background, especially when they realized I had any aptitude for maths. I was kind of directed in this direction kindly. But I also had a plethora of other interests. I was part of choir. I loved school sports, team sports even, sorry. And I loved debating and public speaking. So my first experience with engineering was when I did working experience in TY, which I'm sure most of you have surpassed at this point. And I did a program run by Engineering Ireland with TUD Engineering, where they chose 100 students from all over Ireland to come and kind of see what it would be like in college. And that experience was great. But the only thing was, it was my first interaction with kind of the engineering ratio. There was, like I said, 100 students and there were 3 girls, which was disappointing and confusing to me, because obviously I'd always had that presence in my life, my parents saying it would be an option. And I know a lot of girls didn't. So great to see so many girls here tonight. I'm hoping I can maybe do that for you. But that's getting better. I know in my year, there was 34% girls, I want to say. And I think the year after me is even better. So it's definitely better than the 3% that I experienced first. But even after my work experience, there's still other things I wanted to explore. I knew I loved my team sports. I liked working with people. I did role work experience. And I liked the idea of that. So when it comes to choose my school subjects, I was kind of at a loss. I did a real mix. I did applied maths, physics, economics, and music. And I didn't really know what I wanted to do. But that's okay. I'm sure a lot of you are in the same boat now. And even if you aren't doing STEM subjects, is something I'll talk a little bit about later. All I can encourage you to do is a lot of research. And once I did land in engineering, it was generally because while I loved maths, I kind of preferred the idea of applying it to solving a problem rather than kind of the theoretical studying the background to it, which kind of comes with general science. The idea of kind of going back to that Lego, getting to build something, coming up with a product really appealed to me. And then once I decided on engineering, it was YUCD. And I'm sure a lot of you have attended the open days, just like I did. And I was taken aback by the magnitude of the place. Fun fact from the 2023 census, there are more students enrolled in UCD than there are people living in Leitrim. So this place really is like a village, to put it into perspective. And you really get that. There's really someone and something for everyone. Like they said, there's over 60 societies, over 50 football teams, sports teams. And I've really found that everyone kind of does find their people, which I know some people were expressing worry about. So like everyone said so far, it's a general first year and it really just kind of feels like catch up. Whether or not you've done your STEM subjects, whether or not you've even thought about engineering and you kind of ended up here, it's really a great opportunity to kind of try everything and just kind of bring everyone up to the same level. I know a few people I was talking to outside were kind of worried saying, oh, I haven't done this, that or the other. That's okay. One of my friends came in having only done ag science and he's doing just fine. So it kind of gives you an opportunity to kind of, it's very scientific for the first year, kind of less engineering, more science-based to kind of get everyone up to that general standard. But it's great, it kind of gives everyone the opportunity. Nobody feels behind then going into second year. You might struggle a little bit, like I know I hadn't done chemistry and hated it, that's okay. But it does give you the opportunity to catch up. So no one's behind then when you do pick your stream. I know a lot of people as well were asking me outside about kind of the split between coursework and like kind of more technical academics. And there's a really good split. Personally, I love the coursework a lot more than on the academic side of things. But that's great. A lot of modules, I think the like most weighted exam I've had is 70%, which might still sound like a lot, but if you're comparing it to like law where it's 100% exams, it's great to kind of go in with that pass already from your lab components. So here's just a few examples. The far, I don't know, left or right, but the calculator, the one with the keyboard, is a project that I just recently finished. So kind of straightforward to build a calculator. Which is exciting. It was kind of great to get 2 + 2 = 4 and have it be groundbreaking for the first time since maybe junior infants. So that was really fun. And then the second one is one you'll do in, I think it's second year? No, first year, because it's general. So it's a mechanical project. The idea was to build a structure out of straws and string, which could maintain a bottle 500 milliliters a meter off the ground. And this kind of was the first time as well we got an introduction to the idea that there's no one correct answer to an engineering solution, like problem. There would have been, I think, about 50 teams out of the whole 300 people in the course. And every single person had such a varying structure. And it was kind of such an interesting thing because everyone had gone away, worked with their team, come back and they presented, and everyone's was so different. So that was something I found really interesting. And then this next one is something anybody doing physics will be studying, which is really interesting. I think it's, you guys will probably know more of the physics than I do at this point, but it's a DC motor. Kind of getting to see it working. Kind of again, really highlighting that whole, you study your theory in the lab, in the lectures, then getting to apply it in the labs, which is something I really loved about engineering. And then I have one more slide. Oh, here we go again. Okay, so here, this is another project we did, kind of highlighting the engineering process. So you go away, you start studying your lectures, you kind of learn the concept, you come together with a group of people you don't necessarily know, which is a challenge in itself. And you come up with a prototype. So the whole idea of this project was to build a structure out of an A3 sheet of wood that you could cut up with lasers in the lab, and you had to build a structure that could withstand as much weight as possible. So we went away, went to our lectures, attended, learned all the theory, met as a group, did the maths, built the prototype out of cardboard, as you can see, then went to the lab and built our structure. This is it here. And this is the video as well. We applied, have you heard it? It said largest load so far, proud moment. But if you apply it, just kind of, you can see how much weight it could withstand before it kind of shifting. And in the end, ours could hold the weight of a Mini Cooper. So it's kind of cool to kind of, you know, do the maths and you get all these mad figures when actually be able to apply it and see, oh, wow, okay, it actually does work. It's really, really cool. So next, that's kind of an idea of kind of the split. But then, as you guys have all heard, there's a lot of different streams. I'm doing electronic, and I feel like people are asking me outside, what is it? Why did I choose it? So kind of everything to do with electricity is the easiest way to put it. So for everything so small from your phone to a tiny microchip to as big as like energy generation and windmills and as big as it can get. Why did I choose it? To me, it was modern. I really like the idea of like technology is moving so fast. There's a thing called Moore's Law, which states that every 18 months, the power of a computer basically doubles. And like to think about how many 18 months am I going to be working in this field, how strong a computer is going to be by the time I'm finished. It's just breathtaking to think about. And even AI, everything, it's just moving so fast. And to be a part of that change was really interesting to me. There's definitely challenges. We're kind of moving away from that whole tangible part of engineering of being able to see a thing change. You can't really see electricity. So that was definitely a challenge I have on the daily, not knowing where my problem is and not being able to see it can be hard. But I still love it. And the coding design modules are definitely my favorite. Designing things like a calculator, we've designed an alarm clock, we designed a prime number detector. All these things are really, really cool. And then again, somebody mentioned earlier about the elective program, which I've really enjoyed. Like I said, I loved economics in school, it was my favorite subject. So I got to explore that through the elective program. I also love music. I played the violin. I did a music module in my first year. It's just a great way to kind of expand your horizons and think about what you might want to apply your degree to once you leave college. So then these are the 3 words I would use just to describe overall my experience in engineering so far. I'd say it's been collaborative, challenging, and really social. So to begin, collaborative. If you can't tell from all the photos I've shown so far, you're never by yourself, whether it's in your lectures, in your labs. There's a picture of me and my friends having a group study session before a maths exam this year. You can't get away from people, and that's how engineering is. It's always about working in a team and kind of understanding how other people's brains work to kind of come together to solve a problem. So there's like a plethora of labs and study sessions and everything. And it's great. I love it. It's way easier to talk through a problem together than it is to work on it by yourself. As people say, problem shared is problem halved. And that really applies to engineering, I would say, in my experience so far. Challenging. No one's gonna lie to you and tell you that engineering is an easy degree. It's not. It's long days, early starts, late nights. I've had a part-time job my whole time through college. Kind of achieving that work-life balance can be really hard. I play school sports still. And it does just mean sometimes kind of making sacrifices that your peers mightn't necessarily have to make. And it can be conceptually challenging. So that's just the main piece of advice I'd say to all of you is just don't be afraid to ask for help. That applies even now in school. Kind of emailing your lecturer when need be, asking a peer if you just need extra help with something. And not being afraid to kind of rely on the network that is there for you is really important, especially in this degree, because it's challenging and nobody's saying it isn't, but it's possible if you're willing to ask for help and kind of put your pride to the side sometimes. And the last thing I'll say is that it's really social. I've made the most amazing friends in this course because while the hours are long and the course is big, there's more people in this course with me than there was in my whole secondary school. So that was a challenge going in, but well, as you are in that kind of 9 to 5 full-time job kind of hours, you're with the same people every day and you do get to know the same people. And because it's so collaborative with all the labs, you make such amazing friends. And there's been society balls, informals. I'm a part of a few different societies. And that's always fun. You know, you do get a chance to have fun too. Don't want to scare you all off. And there's great on-campus life. Me and my friends every Thursday, we meet up by the lake after our labs and we get burritos from the food trucks that come to UCD on Thursdays. It's kind of nice to sit outside, kind of get away from the labs and just chat about something that isn't engineering for a while. There's a 5-a-side tournament there run by EngStock that I took part in and won recently. That was so much fun. And then we've gone on class trips to Budapest and Prague, which again are kind of just, it's a lot of work, but there's definitely a work-life balance that you can strike and is really rewarding when you do. So then finally, what is to come? I'm the same boat of a lot of you now. I have a big decision ahead of me in March. I have to decide whether or not I want to graduate after 3 years, whether I want to go on with the 4 years, or do I want to do 5 years and do the master's? And I'm kind of thinking about it in the same way I'm sure a lot of you are. As mentioned earlier, UCD have a great network behind me. They have organised career fairs, which I've attended and been able to talk to past and current pupils at. There's been talks from my lecturers about my options and they're kind of talking to friends, which is really, really important. But the last thing I will say to you guys, I suppose what I want to do, I'm thinking of doing the master's. It just really seems like a valuable experience with the internship and everything worked into it. And also there's a business one, which I think was mentioned earlier, but it's kind of an integrated business master's, which I'm definitely looking at because I loved economics and business in school. But the last thing I will leave you guys with is to think about what you want to do. It can be so easy, especially in school, to kind of get wrapped up in what my parents thought I wanted to do, but I ended up here and I'm happy. Or kind of what your peers are thinking, where they want to go, what they want to do, but kind of it is a personal decision and not to let that sway you. If anything I've said to you kind of tickles your interest, kind of like, were you that kind of girl who loved doing Lego or Sudokus when you were younger? Or do you like team sports? Do you like working with people? Do you like solving problems? Then if so, engineering could definitely be for you. And it's definitely something you should look at. So I'd encourage all of you to come up and ask us questions afterwards. We'll be hanging around. So thank you guys so much for listening.
Hi everyone, my name is Eleanor and I'm here tonight to chat to you a little bit about a graduate's perspective. So I studied chemical and bioprocess engineering. I did both the bachelor's, which was a 4-year degree at the time, and then the master's, which was a 1-year degree. And before I go into why I chose engineering, what the degree is like and what I'm doing now, I'll give you a little bit of an intro into who I am. So I am from Mayo. I came up to UCD to study. The only time I'd been in Dublin before was for pretty sad occasions, came back empty-handed. So swallowed my pride to come up. When I was young, I was the ultimate Barbie girl, very on trend right now. And I played with my dolls all day long. And sometimes I'd be thinking, oh, my Barbie house needs a sunroom, needs an extension. So I very much became Builder Barbie, got all the Lego, got all the Jenga, whatever was around the house, and started building massive Barbie houses. So I think before I knew I wanted to do engineering, probably a lot of other people did. But that's kind of key because I really didn't know I wanted to do engineering right up until where you are right now, so in 6th year. So you can see from the subjects I had studied in school, they're pretty broad. So I did maths, biology, chemistry, accounting, French, English, Irish. So I hadn't chose physics, hadn't chose applied maths, really wasn't thinking about engineering at all, to be honest. I had done work placements in a vets and an accountants and an architects. I did French exchanges. I was all over the place with what I wanted to do. But then when it came down to kind of 5th year and 6th year, I really found a love for maths, for chemistry, and I started really digging into what I wanted to do, and ultimately was trying to decide, I suppose, between either a science degree or an engineering degree. I started coming to a lot of open days like this all over the country, to lots of different colleges, started looking at all the different booklets and talking to people in my class, in school, teachers, parents, lots and lots of different people. And ultimately, I decided on engineering because I liked the practicality of it. And I think Grace said that earlier, that I thought I would get a more hands-on experience, maybe something a little bit more industry focused. And I liked the fact that it was really broad, that I could do lots and lots from it, and I didn't have to decide what job I wanted just by deciding what course I was going to do. So why did I choose UCD? So I came up to the open day and a little girl from Mayo, I was jaw dropped when I saw UCD. I liked the amount of streams, I guess, that the engineering group had. It had almost the most streams out of all the colleges I'd been to, and I had a little bit of an interest in chemical engineering already, just because I had studied chemistry in the Leaving Cert. So I knew UCD did that course and felt like I wanted to at least have an option to do it here. I also like the fact that first year was general and you would get a taster into all of the different types of engineering. And then I'll echo, I think, what a couple of people have said, but I like the idea of having electives. So having the opportunity to do different classes that you might never get to do outside of your degree. So I got the chance to do French, Spanish. I did food, diet and health. I think I did massage. So lots and lots of different random kind of classes that really gave you a good rounded experience. So at the end of first year, I decided that I wanted to do chemical and bioprocess engineering. And I do have the definition, or the Wikipedia definition of chemical engineering on the screen. It's a bit of a mouthful, but it is a branch of engineering that uses principles of chemistry, physics, maths, biology, and economics to efficiently use, produce, design, transport, and transform energy and materials. So lots of words there. But I chose it because I loved the taster class in our first year. I loved how you got to use lots of different sciences in the one degree. I looked at all of the different classes that we would be studying, I guess, in 2nd, 3rd, 4th year, and was really interested in them. But on top of that, I liked the fact it was a really small class size, and all of the people in your class were together 24/7. So you do become very, very friendly. It's a mix of individual and group work with lots and lots of interesting projects and very approachable lectures. I'll say that for you, Phil. And to give you an idea into what type of projects we would have done, I've just snapped a few of them here. So I'll start with the smaller one, which is the Heart and Lung Project. So we did that in our 2nd year, so our first year of actual chemical engineering. I don't know if it's still on the go now, but it was a group project where we looked to actually physically build a heart and lung machine. So we were looking at what type of piping we needed, what type of temperature did the blood need to be at, and how did we make sure it stayed at that temperature? What type of pump did we need? How did we get enough oxygen into the blood? So you were working with a team to actually design that and then go into the lab and actually build that and hope that your blood stayed in your system and you didn't have any leaks. So that was a really fun project in 2nd year that really got us kind of all working together and thinking about all of the different kind of sides of chemical engineering. And then the other 2 projects I have here were both done in kind of 4th and 5th year in chemical engineering. So the design project there, and I don't know if I'll be able to pronounce this anymore, it was a few years ago, but my design project was design a plant to produce L-phenylalanine and L-aspartic acid. So that was also a group project, and it was very much kind of theory based, I suppose, where you went and you actually had to look and design that full plant, and not just from an engineering perspective or a technical perspective, but you had to look at health, environment, safety, planning. So it was a really holistic project that you got to look at a lot of different things, and has definitely been helpful in actual work and industry. Another project then is a research project that I completed. So most people in chemical engineering will have to complete a research project, and some people do that when they're on their placement, which I'll talk about a little bit later. Some people complete it in college. I completed it in NIBRT, which is almost on the UCD campus, but it's the Institute for Bioprocessing Research and Training. And it was a lab research project that I did. And the title is there. It's also a bit of a mouthful, but it's developing and optimizing a small scale fed batch process for recombinant protein production in CHO cells. So I had never really been in a chemistry or bio lab. So that was something I really wanted to gain a little bit of insight into. And that's one of the reasons why I veered towards working in a lab for my research project rather than doing it in industry. So hopefully that gives you a little bit of a flavour into the different types of projects that you would or may do in chemical engineering. And the next thing I wanted to chat about, which I know has been chatted a little bit about before, but is the Erasmus or the junior year abroad. So in third year college, you do get the opportunity to potentially go away if that's something you're interested in. There's lots and lots of different universities. I just have the US on the map there, but there are lots of options outside the US. You can go for a full year, a semester. You do have to keep your grades okay first and second year, but when you are away, then it is a nice pass-fail year. So you can definitely immerse yourself fully in the culture and not be too worried about grades. So I was lucky enough to go to the University of Texas at Austin for the full year in my third year. Had the best year, would definitely recommend it if anyone is even considering it. You're definitely thrown into a situation, you don't know anyone, but made the best friends that I'm still friends with now, got to travel all over the US, tried out a brand new culture. I'd never been to the US before. I'd never come to terms with Texas barbecue, but also similar to here, got to try out lots and lots of different classes. So got to do a class in basketball, and I'm only 5'2", so it was tricky. Got to do science outreach where we went to elementary schools and taught kids kind of basic science principles, but just had a great year. So definitely, if there's a takeaway, it's definitely something I would recommend if that's an option for you. So after your junior year abroad or your third year, there are options for internships. So in third year, after I came back, I decided to do a 3-month placement in industry. And I went into AbbVie in Sligo, which is pharmaceutical industry. And really that 3-month kind of stint is just a really quick introduction into industry, into working as a professional. What would this be like? And you kind of get a flavour for what type of things you would be doing in the workplace as a chemical engineer. Once you've come back, and if you decide then to do your master's, there is the option to do an internship, or I think you have to do an internship, sorry, for either 9 months or 1 year in this course. So you can do your research project, like I was saying, in industry, and in that case, your internship can be a year long. And if not, you can just do the 9 months and then come back and do a research project, which is what I did. But that internship really gives you a really deep technical understanding of what you will be doing post-college. So I did my master's internship in AbbVie in Sligo as well. So I went back to that same company and worked in kind of a different facility there, and really gained a lot of knowledge as to what I would be doing after college. And I know a lot of people say, oh, I don't use what I learned in college in my job every day. And that was absolutely the opposite for me. So everything I had done in college was translating exactly into the job role, which was really nice to see as well, that what you were doing in college was actually representative of what was going to be the job. And just something to note at the end, I've popped there, but something that sometimes we don't think about is the soft skills that are so important in everyday life and in a role and in a job. And that's something that the internship really gave a lot of people as well. And finally, job opportunities. So this is my class. We graduated, I think, about four or 5 years ago. So I think there was about 30, 35 in my class. And you can see the list here of different areas or industries that people in my class went into. And the top one really is pharma, I've typed, and biopharma. But Ireland is a booming place to work in pharma or biopharma. They have all the top companies, and really a lot of chemical engineers do work in that industry. But there are lots and lots of different options. So we have design and consulting, which we touched on, or someone touched on a little bit earlier. So you have to design a lot of those facilities. So you can work in design houses to do that. There's oil and gas, food and drink. And then there's also things that people in my class did that, don't have anything to do with engineering. So some people went back and did accounting exams. They're now accountants. Some people went into stock trading, and some people stayed then and did research and PhDs and that type of thing. So where am I? So right now, and I didn't put the company name, but anyway, I work in a biopharmaceutical company called Bristol Myers Squibb in Blanchardstown. I came out of college and went straight into a graduate program with that company. And what that was basically a rotational program where I could try out lots of different teams and gain skills from each of those teams, and then eventually come off that program. So you can see the 3 different teams I was in on that graduate program. So I was in a manufacturing role. So the facility itself is a manufacturing facility. So it's very large scale, and we're kind of manufacturing drug substance there. So I was able to go onto the floor, see all these, 15,000 litre bioreactors, 20,000 litre hold vessels, and work on the floor and kind of gain an understanding into the actual process. And then moved into a supply chain role where I was mapping production, and it was much more kind of desk-based, but also in that role got to do a diploma in project management, learned a little bit about Lean Six Sigma, and from that role then went into an automation role where I did a lot of the process automation and kind of more on the coding kind of side of things, which was also a little bit more desk-based. But it just gives you an idea of the different types of roles you can do with that degree. So after the program, I went into another role on the site, which was in projects. So kind of used the skills from all of the other roles and from college and internships and everything else I'd done in that role there. And currently now I am in supply chain. So went back into one of the roles that I had as a graduate, and I'm still there now. And I think it just shows that, you don't have to have a load of technical experience and have to do an engineering role. There's lots and lots of different options and roles that you can do from engineering. And all of those skills that I had in college still help me today in my current role. And just to conclude, I popped a few bits down that when I was creating the slides, I was trying to think, what do I wish someone would have told me when I was in your shoes? And the first one was not to get worried about that your Leaving Cert subjects don't kind of fit into the course you're looking for. So I was so worried that I hadn't done physics, hadn't done applied maths. And all in all, it didn't really matter because, like Grace was saying, first year really just builds you up and gets everyone on the same level. The second thing is to look into your course modules rather than the entire course as a whole, and think about whether you'd actually enjoy doing those classes and doing those modules. And if you think you would, maybe that's the course for you. I also found the general first year really, really helpful in doing all those taster modules and then helping you decide exactly what you wanted to go into. And 2 final ones then, just to say yes to every opportunity. So study abroads, internships, jobs, programs, throw yourself into everything on campus, societies, teams. It's only going to do you good. And finally then, just to say that engineering is super broad, diverse, and there's so much opportunities. It doesn't pigeonhole you at all. You can do anything you really want from it. And hopefully that's highlighted there. So yeah, thanks very much.
Very much, Eleanor. So just while our speakers are coming back up, I might just, before we kind of get into the Q&A and kind of get too deep into that, I really just want to thank the 4 speakers that we had today for those presentations. Hopefully they've given you a very broad kind of, I suppose, insight into what goes on. And so before we get to the Q&A, we just give all 4 of our speakers a round of applause. Very much. So we're going to turn the spotlight around and it's over to you. So as I said, this really is not anything at all that you're thinking about. Please open up the floor. We're here. We really want to answer any questions you have. So I'm going to I suppose open up to see, does anyone have anything they'd like to ask any of our speakers to get the ball rolling? Won't be shy now. Yeah, thank you.
I'm curious if you do your general first year and you want to go in a particular discipline in second year, how is it allocated if there's a full subscription or what are they?
There isn't, well, either of us can, there isn't a specific size that At the moment, we kind of let people make their own choice, and we can have the capacity to handle the numbers that come into each of the streams.
Are you locked in on that decision early on in first and second year, or is there room for any number outside of that?
There's a bit of wriggle room, maybe Grace, you might take. that.
Definitely. This is something actually we kind of weren't as informed about. It's kind of once you get there, you realize. But in the first few weeks of second year, people can swap in and out, and kind of no worries at all. Even I've had friends swap out at the end of second year. So even a whole year later, and they just have to catch up because there's a lot of overlap between a lot of the streams. So mechanical and elect overlap a lot, same with biomed. So kind of swapping only means catching up on maybe 2 or 3 modules. So it just means maybe they might have to do 1 extra semester at the end or catch up on 1 module per semester, but it's definitely doable and you're kind of never stuck, I would say. So yeah.
Something that's a normal like, so especially when we see them coming through the school, like everything's handled on a case by case basis, and always what we make sure is that people have covered the right bases as they go through, but every case we do that on a case by case basis. We're always going to want the student, they want to do something, we'll try and do whatever we can to help them do that. It's always going to be, we'll want to try and facilitate it. Seeing as a representative, do you want to, do you have any comment on
What country?
that maybe available to you? when you
Yeah,
want
I
to
think when, hopefully you can hear me, when we went abroad or Aria went abroad, a lot of people did go to the US, but people went to Canada, France. I think a couple people went to Australia. But they do have, and I don't know if it's available, but a full list of different universities available depending on what course you do. So it does differ a little bit depending on which stream you're going to do. But that was where my year went. Most people to the US, but definitely there are other options.
When you're looking at a college board, if are the exams that you take to go into college, are they based on college that you want to go to, or is there a general exam that you for international college?
So there's no actual exam to go abroad, so basically as long as your, I suppose your GPA is at a sufficient level to be allowed to continue on, at that point it's more of an application process as opposed to any particular exam. Do you want to
I think you don't have to do an exam. Your GPA has to be a certain level, and you have to write, I think, 500 words to say, you know, why do you want to go abroad, and you put a preference then 1, 2, 3 on what colleges you'd like, and once that application goes in, they'll get back to you then on whether you've been successful on which placement or preference you can get type thing. But once you go over there, then it's just as if you're here, you just take your classes and do the exams that they do, which will be equivalent over here.
Is the list available of the modules that are like offered for the course?
Yeah, so they're all available online. I know, I think there was Paul had a kind of a snapshot of them, but there is a detailed. So each one of the disciplines will have its own kind of website, on the UCD website, that'll have every single year broken down. So it's quite intuitive. You can kind of walk through them. But again, if you're there afterwards, we can kind of direct you to where that is. But it's the UCD website, and if you search, even when you go into Google and search for mechanical engineering UCD, the first thing that will be the homepage, and it has a very detailed breakdown. Year by year, exactly what you study.
Is there a lot of catch up like after your
No, it depends, I think, what college you go to and how closely you match your classes. So you do have to look at what modules you would be doing in UCD third year and go over to the college and make sure you've matched those. For some people, if they had missed 1 or 2 modules, they would have had to catch up on those when they came back. But I don't think I had to do any extra modules coming back. Some people had to do 1 or 2, but on a whole, not really. No, it was fine.
So just on that, those agreements for the study abroad are very much a very kind of coordinated process. So you don't just kind of decide yourself. You do have to prepare an application, and you do have to map out maybe the stream that you're on to particular other particular streams in other universities. It does give you extra choice, but it, you don't kind of go necessarily from electronic, into bioprocess engineering. You don't have that amount of flexibility, but you do have to map out, and there's a process to support you to get that mapping process done before you'd go.
Is there much difference in the cost of the different countries you study?
Are you talking cost of living or kind of fees? So fees are kind of standardized, so it doesn't change for you per se.
It's just like cost of living.
Essentially, but it's as if you're a UCD student, essentially,
living abroad, but the cost of living obviously will be separate. Fees wise, you can go to American university, but you're not paying American fees, you're paying the UC.
For students who don't participate in the Erasmus program, what is student life and the college life for them to do?
I suppose it's very similar to, I suppose, in a way, what would be second or fourth year as well. So like they have a normal academic year. The difference, I suppose, between going abroad is that you're kind of substituting the modules that you're doing in UCD with the modules that you're doing in a different university. But if you stay in UCD, you will still continue through the majority, again, just to say, like most students, not the majority do stay in UCD. It's only wherever those students that want to go abroad will do it. But it's a regular kind of I suppose year in academic life in UCD. If they stay, that the modules be as I suppose set out in the course criteria. But yeah, it would be a regular kind of year, you know,
I'd just add to that though as well, if I may, UCD is a hugely internationalized campus. So even if students choose to stay in Ireland, we actually have a huge number of international students come and visit us. So, you know, students that stay in Ireland do get a hugely internationalized experience as well. Again, to interact with people from absolutely everywhere, to be honest.
That's definitely. One of my fortune modules, it could be up to about 20% coming over from America, making up those modules. So yeah.
Yes. It's a very significant.
In general, for first years, what would be module or subjects are the most difficult things to do in 6 years?
I'll maybe hand over to the Chris.
Yeah,
Actually, there's on there's 270 students. How many of them progress in second year on average?
Well, I can answer the first bit about the kind of the challenging modules. It's kind of, I would say, very dependent on what you had done for Leaving Cert level. So like I mentioned earlier, like I hadn't done chemistry, so I found that challenging. But then anyone who'd done chemistry was kind of just like, well, this is just Leaving Cert chemistry. So that's kind of very tailored. I know there's a coding module, which is kind of generally found kind of challenging. But other than that, yeah, a lot of it's like you do physics, you do chemistry, you do coding, you do like a circuits module, there's creativity and design. There's kind of a real general thing, but I would say it's very personalized to what you've studied before and kind of your personal struggles. So it's kind of tailored. There's nothing that I would say is generally really challenging. And then I'm not sure about the dropouts.
Not sure either.
It's called the retention rate. So basically going from first year into second year, do we retain those 300 students? And generally speaking, we do. You know, when you've seen the points levels that people are coming in at, and that's the minimum points level is at 566. We generally have an excellent standard of student retention is generally speaking not an issue. And where we do see, because if somebody hasn't done, potentially, you know, mentioned before that they might have struggled with chemistry, it is a catch-up year in that chemistry. It isn't, you know, launching straight. We expect that large numbers of students haven't done each of the subjects that they have to now do in first year. So there, most of those, the types of learning, you will have tutorials, and they're much smaller groups. Somebody who's done chemistry for their Leaving Cert and, you know, done super well in it may not need to attend the tutorials. They can go off and do, you know, French if they want. But, you know, the different supports are there to support each level catch up in each area. It's designed specifically like that to, you know, we want people to get through to second year.
If you're from Northern Ireland, can you still participate in the Erasmus program?
I think you can.
John Haley, John Daly.
I haven't got the detail at the top of my tongue, but for the A levels as well, I think it's 4 A levels. There's some specific requirements there as well. So we can get the details on those. I have in the notes there.
Yeah, 4 A levels.
I just want to thank you all. Thank you. Very good stuff. Do you have any way about dealing with students coming from different countries who finished? I come from Gaza recently, a month ago, and I was planning to be in the IG. I finished 1 year and 3 weeks with that students. So yeah, do you have any way of dealing with students coming from?
So coming through a non-traditional entry route is really, I think that's the question.
Yeah, exactly.
So there are, this is not necessarily straight through the Leaving Cert or the CAO application here, but there are other non-traditional entry routes. I think there's a percentage of spots, of the 300 spots available each year available for that route. I don't know the exact.
Then it's okay after giving me your specifics, I can talk you through what options are available to you.
Could I ask you to repeat that, sorry? Industrial placement, is it?
Yeah, so I think Eleanor was talking a bit about this. Would you want to maybe just give
Yeah.
another little bit of recap on it?
Yeah, of course. So there are options to do summer placements, so 3-month placements in industry. And then also if you choose to do the master's route, there's options to do 9-month industry placements. So lots and lots of options, whether you choose the ME, the BE, the 3-year, you'll either be doing summer or longer into industry placements there.
Our supports, there's so many, how difficulty with a particular subject. To say, over the last argument, we're struggling in first year, and the coursework and the go within the law, but they're difficult support.
So yeah, there you go.
Well, there's actually a math support centre in the library, which is available for all first and second years. It's a mix of students and tutors. And it's available for any module, whether it be business or engineering, for anyone who's struggling with maths in specific. And then other than that, yeah, there's like there's tutorials where you have that kind of opportunity to go up to somebody and they can kind of help you go through a certain problem that you're having. And also in my experience, I found lectures have been really helpful. Like I've had lecturers invite me to their office to go through a project kind of one-on-one before. Like there definitely is a support network there if you are struggling with something in specifics.
Additionally, just when you join UC, you kind of come in the first year, there's a couple of different things that happens. First of all, there's, I suppose, the formal support structures. So what Grace talked about is absolutely bang on. That's exactly the type of structures that are there for you, that you can reach out to as you go through the, I suppose, the 4 or 5 years, whatever length you're with us. But it's also kind of formal kind of mentoring kind of process as well. So we have we have kind of formal sports in the school, but we also have things like peer mentors. Like so when you come in first year in UCD, one of the first things that happen is you're introduced to kind of a group of kind of peer mentors, etc. at the start, that are there on a kind of a softer basis, just if you need to talk to someone about, for example, I'm struggling with my coursework, where can I go find out about things like the Math Support Centre and stuff like that. So there's a formal kind of mentoring process that goes through with you as you go through your undergraduate degree as well. So the idea is that you're not really meant to be left on your own. If you're struggling, there's always someone to reach out to. And for pretty much everything, there'll be someone somewhere that can help you, even things like you're struggling with written English and stuff like that. I had an example of that recently where someone needed support in that, and we were able to find different kind of services in the university that can help them. So realistically, there's always going to be someone who can help you. It's just about making sure that you're connected in with the right, I suppose, supports from day one, which does happen in the first couple of weeks when you join.
What kind of support do you have for people that maybe learning is coming into school?
Do you want to maybe?
Okay, so it depending on what is getting specific there, just part of that support rather than the peer supports, there's a student advisor for each college. There's a whole team of student advisors indeed. There are a couple of people named for each school and for each college, but it's a wide team and they've got different professional expertise. So there is that range of support there as well, which can be tailored to, because there's such a diversity of potential problems or potential issues or things that a particular individual might need a bit of support to get over. It's a very, very wide team of expertise in the student advisors. So whilst they might be officially associated with the College of Business, for example, they actually might come on board and support a student in engineering as well.
What kind of jobs can you get a PhD in, like mechanical?
None of us are actually mechanical.
No, wrong street shoes.
Sorry.
Sorry, yeah, so head of mechanical, so you could work in academia, so you could end up like me, I worked in industry first, or you could work for some in research roles in industry. So for instance, Intel hire a lot of people with mechanical PhDs because you put a PhD in material science and engineering. And so people out of material processing from the medical device companies that the speakers talked about. You're looking at kind of the higher level R&D, being in the R&D centers in some of the big companies around the world. So people who come out with a mechanical PhD, they can go probably 50-50. They can either go into academia or they can go into industry and go into industry roles.
Thank you. Good to you. You were saying that you were also doing a part-time job.
Yeah.
As well, so 40-hour week that you're studying, you in Monday to Friday,
Mhm.
8 to 5, 8 to 5, or whatever it is. How did you find, how many extra hours did you need to be able to put into your studies on a day, on a weekly basis in order to kind of get yourself to allow yourself to an opportunity to work?
Yeah, it's very tailored, I would say, first off per year. So say first year, you kind of have, depending on maybe how you're finding certain modules, you can have more time. So I think I worked 2 days a weekend, so either Friday and Saturday, Saturday, Sunday first year, and then occasionally 3, but very rarely 3. And then come second year, and now I'm only working 1 day a week. So it's like I am maintaining, but it's also just tailored per week. It'd be great. My job's very flexible. They are very good for if I'm saying, okay, I need this week off. They're quite good for that. But most people, I think I would say 60 to 70% to 80% of my friends had jobs in first year, then maybe dropping a little bit in second year, and then third year again dropping a little bit more. But it's definitely manageable. It's kind of like any extracurricular. It's kind of about time management. So I know like a lot of my friends say are playing sports at maybe a higher level than I was. So they had that time gone to dedicate to that, but I had that time for my job. And it also then depends how much extra time you personally want to put into your studies. So like you can put any amount of time into anything. So I kind of had to make sure that I got up early in the morning and did my assignments so I could go to work and then come home if I had to finish it. So it's definitely challenging, but I think that's all part of anything in life. You kind of have to make sure you're able to prioritize. And it's definitely possible. Okay, you are looking at 24-hour week when it just comes to lectures and like labs and stuff and tutorials. Then you do have the hours there on the weekends and stuff if you kind of dedicate your time right in the week to your assignments.
And that if we're looking at kind of on an average of the college, about maybe 30-40% of students will have a part-time job kind of within the year. And then obviously a lot of students might just have summer jobs or things like that. So it really does depend, I suppose, on point in time and individual student.
And the contact hours then, for each year and across each program would vary a little bit, but I suppose around an average of around 20 to 21, 22 hours per week contact time. So that means essentially once you're thinking of it in terms of that your degree is your job for those 4 years or 5 years that you're doing it, it's around 50% of that time you can, be flexible about how you're going to approach it, because you just have to, be present for the contact hours, so to speak.
Question on the grading in the college. Does the GPA start in the first year and count it all out through the 4 or 5 years? And what happens if students fail the subject year? They're reduced, fail the 2 levels of math.
Well, you can take this as well.
Yeah, your GPA is building up as you go through. I suppose like the weighting increases as you get towards the end, so your most important modules are the ones when you get to 4th year, but the benefit of it building up is I suppose you're being awarded for all that hard work. It's not the case where you work really hard for 3 years and then you put 4th year, you one big exam and it all rises and that's up. You're gradually building it up, with the most important weightings being for the latter half. In the worst case scenario, if something happens with an exam, look, there's always a mechanism to standards. If you have, say, an exam in the summer and you don't pass that module, typically what happens is you'll continue on with everything else, so there's nothing that happened, but you'll do what's called a resit at the Christmas exams. So basically, you and anyone else who failed that module will come in and they'll do an exam, it's a recent exam, and that basically, now you come through that module at a pass level. If you get through it, you come through it at a pass level. If that exam doesn't go correctly for you, you come to the following 1 year on from the time when you originally set the module, and basically you then have to do what's called a repeat at that point. So first opportunity to redeem yourself is a resit, where you don't have to do the rest of the module, you do your exam, and that can get your pass grade. If that doesn't go correct, the next thing is that you have to basically repeat the entire module, where you have to do all the continuous assessment and everything. Again, you're expected to attend class and all that. If someone's really struggling, again, like in speaking experience in our school, what tends to happen is if workload is starting to build up and it's starting, because you can see how that starts building into that starts kicking into what comes after. It could snowball very, very quickly. typically what happens is, a member of academic staff will sit down and they'll work on what's called an academic plan with the students. To make sure that it's not becoming too much and to make sure that they're actually able to realistically get through it. So look, the safety nets are definitely there to get students through. Like, I remember when my first kind of head school center, the right side, like we are on the student side, that is very much the case in all these situations. We want to get everyone through it. So like, yes, there's formal systems, repeats and resets, but I said if it starts becoming too much, like basically that's where things like academic plans and that kick in to try and just how can we help that student balance their workload and get them through, because at the end of the day, all we need to make sure is that we get from A to B and how that's done can basically be adjusted if it needs to be, you know, but the definite system there for all situations.
Yeah, I can testify to that. I've had peers fail modules and the support system is great. And definitely actually I would say in comparison to other universities, I have friends in other colleges and they're not technically as good for kind of keeping you moving forward. UC are very good for, like, you can fail modules semester 2, but you'll still be able to progress the next year, no worries at all. And it sometimes adds a little bit to your workload come exam season. But it's generally doesn't hinder the rest of your college experience at all, I find, from anyone I've spoken to.
What like degree would be like suitable for like developing new private technology?
I think that's a broad enough question in terms of the very much depends on the type of, every engineering discipline that was shown there has a form of technology. So again, looking at say, but others working in that in the chemical pharmaceutical space, I mean, that's literally underpinned by nothing but kind of really a bit of technology. I know you were asking about mechanical engineering earlier. Again, by definition, that's pretty much what mechanical engineers do. Grace talked about electronic systems, even some of the images you had on the screen there. You give like 6 examples, every single one of it is one of the different piece of technology. So if I were looking at that, I'd probably start thinking about like what type of technology exciting, type that Bella was maybe showing or Grace was showing, and then every single type of engineering, like what by definition is about developing new technologies. But other than that, anything they want to.
I suppose it depends what your definition of technology is, what kind of technology you're interested in, and then you don't really have to decide now. If you're coming into first year, you can kind of explore all of them to begin with. So it's a good place to start.
Chance everyone.
Yeah.
Well, I suppose like again, I don't do you want to maybe answer this from the mechanical perspective? Yeah. Do you want to pick up on
Biomedical. Yeah, it's actually delivered by, half delivered by it's combined delivery from the expertise across at the 2 schools. So it's very much designed to be both.
The engineering school has with the Nova Centre. So obviously lots of PhD students probably go on, but is there opportunities for grads to work with some of the startups? Or spin-outs?
Well, you probably both take different aspects of it. Yes, is the answer. Students can actually choose, certainly from the electives, even in first year, to take an entrepreneurship or an innovation type of module. There are opportunities throughout each of the programs, no matter which stream you go into, to do research projects. You could, you're generally speaking, that you're given a list of projects or supervisors that are available, in particular areas. Many of the academic staff within the college and within each school, actually, some of them even have startup companies themselves. So you might actually have the opportunity to work with them on a project, or even to have a placement with them, or to have your professional work experience with them either. So it is built in, and if it's something that is of interest, that a person really has a yearn to do something like that, or has that kind of ability within them, there's certainly nothing going to stop anybody from developing their entrepreneurship or innovation skills.
Well, that's it. And going completely with what you were saying there, like ultimately the way to picture something like Nova and Ivor or any of these kind of facilities that are inside UCD is, it's very much, I suppose, up typically to the students find if they want to reach out. There's no one in UCD or anything associated that's not going to want someone coming down with an interest for what they're working on or working with or anything like that. So like if you had an interest in one of the companies that was there, or again, when you're thinking of something, I know you might be thinking of maybe post undergrad a little bit as well. I think it's important to know that that kind of facility exists with those type of people that you can reach out to. I think the biggest thing to know is that, like, basically, as you go through your process, and you reach out, there's no one that's going to turn you away or not want to. If you want to do some research, you know, outside of your formal degree, and just get involved in something, people are going to be delighted to talk to you. So the main thing is to know that those kind of facilities actually exist, and then be able to make use of them, as I suppose, it's the individual students as well.
It's actually going to become more embedded in the next few years. We've just recently received funding for a number of staff members to work with Nova and Enterprise Ireland to actually develop further entrepreneurship programs for 12 students each year. So it's something that is actually going to be increasing in the college.
I think it's also not to underestimate as well. I know that we talk about the Library Centre that's on UCD as well, and that's a huge, I suppose, opportunity for people, especially. I'm being a little bit biased because I'm talking about chemical engineering kind of stream as you go through, but that centre touches on pretty much every kind of biopharmaceutical company that comes through Ireland, and have that on your doorstep. And depending on if you pick the biochemical minor as you go through the chemical engineering degree, you'll be doing modules and lab experiments and everything actually over there. Things that companies will pay a lot of money to put their employees through. So again, it's just to know that these facilities are there, and then you can figure out what's the best way to engage as you go through.
In fairness, I just say one more thing on that. The UCD campus is home to many of the nationally funded research and innovation centres, whether that's through SFI or other organisations. So we home Bioorbic, which is you know, from environment and the circular bioeconomy perspective. We also have IFORM, these are SFI funded national centres with international partners, and all of those academics are generally speaking largely within the UCD. So there's huge innovation in those areas on this campus.
And to be very clear, they're the people teaching the modules. Like it's not separated, it's not if you're doing the research or not doing, like those are the exact people who are delivering the modules day to day. So you get as you go.
I have a question kind of more general on student life and accommodation issues, not being government concerns like taking reports and then maybe subsequently struggling with accommodation. And I'm curious from you guys at point, we hear it all in the media, but is it valid with found how many students are having to commute, how many students are living in their cars, whatever. And I'm just curious if you could shed any light on that.
Yeah, I suppose I went through that struggle. I lived on campus in first year, which is not a lottery, but you do have to go online and try and apply, and not everyone gets on campus accommodation. A lot of my friends would have been in digs, and then after first year, if you don't get on campus again, there is a proportion of on-campus accommodation saved for first years, and after that it gets smaller and smaller. That may have changed now since I've been in college, but after first year then it is up to students, I guess, who aren't from Dublin to find alternate accommodation. Everyone that I know did get alternate accommodation, whether it be digs, whether they found a house, an apartment, whether they shared a room, whatever it may have been, everyone did get accommodation. Sometimes a little further out, and I do think it's, you know, it's very expensive and it is hard to find accommodation, but I don't know anyone that didn't get any throughout my whole time in UCD.
Just to follow on from that, it is still the same. We do have the majority of the accommodation on campus associated accommodation available for first years and international students. That you know, there's no intention to change that. Well, you have a bit more experience, you know.
I guess you know your areas, you know where most students live, and a lot of the time in engineering you'll be friends with other years, and they can partner you up with maybe a house of engineers that are about to graduate and leave, and you can get into those houses. But yeah, you do have to have a good look and be on the ball.
And there is an accommodation support hub as well that actually locates and identifies and has agreements with accommodation offerings in the locality with regards to digs and things like that. So, you know, there's actually a website that, yeah, it is.
Yeah, so while you have labs, which account for a very significant portion of your time, they're all in groups, you kind of can't get away from that. And then if you do choose to kind of go down the electives they're talking about, I know robotics is a huge one people choose, or there's also we're going to actually Formula Student, which is another kind of group project where you work in a Formula One car with your team. So I would say it's a huge portion of your degree is coursework. Generally your exams are only worth maximum 70, minimum 40% of your overall grade. The rest is group work and labs and assignments. So very significant.
No, I'm just very conscious of the time here because the lights are gonna be turned off and it's in the moment. I'm gonna be open now. If anyone has any one quick question, we can have a look. If not. Okay, so what I'm gonna do then, we're just gonna formally call the call. I might just again thank our speakers here. As you get up, we'll be all up in the hall as well, so if there's anything you want to put one-on-one, and hope we will see you all next year. Thank you very much.
Thank you very much. Thanks for really good.